All right, 5.6. I really like this section, but it's very confusing. I mean, you kind of need a roadmap to understand what's going on. Probably the question that, well, first of all, what is 5.6? It's find the real zeros of a polynomial function. We look at our goals, and it just gets lost in the noise. They give you this tool that you may or may not apply. They give you this tool that you may or may not apply. And kind of the number one thing that's not here, let's see, well, actually, all of these tools might not apply to doing what they're asking you to do, which is find the zeros of a function. All right, so let's back up. You've done this before. If I said x squared minus x minus 12, and wrote it as a function, and I said find the zeros, you know what to do. You've done it 100 times in your first algebra class, and you've done it here. You factor. You set each factor equal to 0, and you'll find out that 4 is a 0 and negative 3 is a 0. That is finding the zeros of a polynomial function of degree 2. And so what I'm saying is our number one rule, and it's still true, is to factor. So what's all this? Well, it's essentially saying sometimes you'll use these tools to find the factors, find the zeros, right? And also what I need you to understand for anything to make sense is if you know the zero, then you know the factor. If C is a 0, okay, then x minus C is a factor. Now I kind of turned that around. Normally you factor it, then you set it equal to 0. But in this class, a lot of times we find the 0 first and then wrap parentheses around it in the factor. All right, so I don't want to get, I'm going to sneeze. Well, I'm going to pause. Okay, I'm back. I had to pause it. I don't get bogged down into too much here. I want to get to essentially our goal. And there's a problem. Saw it on 29. Well, the problem started out earlier, but essentially the question was, this is the polynomial, and we want to factor it. So how do you do that? That's what this chapter is about. And it's not 100% obvious how you do this. There are tips, there are tricks. One of them is synthetic division. One of the biggest ones is synthetic division. And what am I doing here? Okay. Now, assume I don't know the answer. But I do know that this thing's going to factor into, at most, 4 parentheses because of that x to the 4. In other words, I'm going to get an x, 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 x minus C1, C2, C3, and C4. I don't quite get that. Well, I guess I do if you allow the numbers to be radicals or, in some cases, complex numbers. But I'm looking for my first pair. And so I'm just going to try something almost at random. Now, it's not going to be almost at random because it does have to be factors of this number here. And 2 doesn't have that many factors. It's plus or minus 1. It's plus or minus 2. So putting in a 1 here was pretty deliberate. I would say if 100 students were doing this, who knew how to do this, 98 of them would try 1. It wasn't random that I tried 1. And we'll talk about curing that randomness, meaning where to look. But so 1 is my multiplier. I'm going to bring the 2 down, multiply by 1. I'm going to bring this down, or add this together. Multiply by 1, add this together. I'm hoping for something. I'll get to what that is in a second. That. I was hoping that was a 0. Because if that's a 0, that's proof that 1 is a 0. In fact, that's kind of what it means. If you put in a 1 and you do this and you get a 0, that means f of 1 equals 0. So kind of out of space here, but not really. I found my first factor. It's x minus 1 times whatever polynomial I get from the synthetic division, which would be 2x cubed plus x squared minus 4x minus 2. Now, if you don't know what I'm talking about here, you're going to need to review synthetic division, but there's plenty of it in this section. But there it is. I found my first factor. Now, that's not how you're used to factoring, but I call this factoring on steroids. We are taking, how much of that I need to erase? Okay. We're taking something like this, and sometimes with no hints, we other than the hints embedded in the problem itself, we take factors of 2, because that's the a sub 0, and put them there. So what was another number I could have chosen? Well, 2 or something like that. So you can see that. Well, I don't know if that, we're not completely done. We still have to factor this, but as luck would have it, you already know how to factor that. Okay, actually, this is a bigger example than I thought. I'm going to go ahead and do it. So, to go from here to here, that required college algebra. It's a skill from college algebra that's not taught in Algebra 1, Algebra 2. But an Algebra 1 student can do this factoring. So, put an equal sign here. And I'm saying, you know what? If I was lucky enough to factor this right here, the problem might be factored. All right. Well, there is a way to factor that. And it's called factor by grouping. You look at these 2 at a time. But the only problem with factor by grouping is it doesn't always work. But I can factor out 2x squared. No. I can factor out x squared from the first 2. And I'll get 2x plus 1. And I can factor out a negative 2 from the next 2. And I'll also get 2x plus 1. And we know that factor by grouping works if the 2 factors in parentheses are accurate, are the same. So if these are the same, this is going to be 2x plus 1. And then what's going to go in the second parenthesis is, x squared minus 2. Now, you might think I'm done, and I kind of am. That doesn't really look like the answer that the book gave me on this particular problem, but that's only because the book approached it a little differently. But I'm saying if you just take a marriage of synthetic division, hoping for the remainder to be 0, packaging that into a factored form, and then whatever technique you have to factor the smaller term, do that, you'll have this. So to make this answer look like the other answer, remember I said x minus c is the way we identify zeros. Well, that's not x minus anything, or I guess x plus, it's 2x. So I can get the answer I have here from Algebra 1 technique to look like the answer that they gave me by factoring out a 2. 2 is not the greatest common factor, so this isn't something we're used to doing, but if I factor out a 2, I'll get x plus 1/2. Why? Because if I divide this by 2, I get x. If I divide 1 by 2, I get 1/2. Copy everything else down. All right. And it gives me this. By the way, this x squared minus 2 doesn't really factor so much. It, if it were a difference of squares, like x squared minus 9, it would factor. But I'm kind of touching into the next section here. But what if it is x squared minus 2, and I was just so interested in getting all of the x minus c's that I can that I'd actually try to factor that last one. Well, you can think of 2 as the square root of 2 squared. So in, I don't know, bizarro world, not quite in complex numbers or more complicated math, 2 is a perfect square. Actually, everything's a perfect square. A is a perfect square if you just write it as this. So you always have difference of squares if you want it to happen. And that means I got x minus the square root of 2, x plus the square root of 2, which I could even factor, I could even kind of tack onto this. All right, let's do it. So yet another way to have factored this, by the way, we call this factoring over the irrationals. So taking this and factoring there. This is a really powerful example because I want you to notice I really didn't use any rule that you didn't know walking into the class. I mean, you knew what factor meant. The language has changed. We're calling this a 0, but if you do the synthetic division from homework R, you know that you can write this as x minus 1 times this factor here. I used an old idea from Algebra 1 called factor by grouping. And again, let me write that down so you can look it up if you need to. It's the factory technique you learned in Algebra 1 when you had 1, 2, 3, 4 terms. If you have 4 terms, you factored it by grouping prior to now. Like I said when I did this, it doesn't always work. But in this problem it did. And so I just want to point out that this problem is kind of like, it's a 6-page problem in the book that didn't need any of the author's of the things the author put in the toolkit. And that's very important in this process. You can factor most problems without using most of the rules the author hands us in 5.6. I really like this section, but what I like about it is just what I'm saying. Very, very rarely would I even use 2 of the, I don't know, 6 tools the author gave us in this section. So the author gave us the remainder factor theorem, Descartes' rule of signs, rational zeros theorem. These aren't tools. These are the bound theorem, intermediate value theorem. I mean, yeah, I might use one. I might use 2 of these, but I would never use all of them to solve a problem. But that's exactly what the author does in these examples, just to show you how the new rule works. All right, so that's kind of an overview of this section. I know I didn't, I almost feel like I didn't teach you anything new. I just told you how to use the stuff that you've known since Algebra 1 and maybe Algebra 2 to do a more complicated problem. But I do have a video on doing probably the most complicated problem that you definitely want to watch as well. But that is kind of my introduction, not my lecture on, but my introduction of this idea of factoring x cubed and higher. And how do you factor x cubes and higher, polynomials of degree 3 and higher? Well, synthetic division is a common one. Just the technique I used in this video pretty much. But some of these others could be tips, maybe tricks, maybe gimmicks that will help you, and I'll do those in another problem, another video. So that is first introduction to the last 2 sections of Chapter 5.